Hey everyone, we're back to talk about functions, but this time we're going to talk about interpreting function notation. So last time you learned a function is a relationship between an input and output, but for every input it should have a unique output. So again, vending machine shouldn't pop out Skittles and Hot Cheetos, it should just pop out Skittles, right? That's a unique output. We're going to continue this conversation by discussing what notation do we use to describe functions, which you may have seen in the previous video, which I kind of ignored. You might have seen this F and this G and this P and wondered, what is that? Well, now's the time to answer. Okay, you'll notice I substituted y equals 3x plus 1 in for that conversation. That's because these things mean the exact same thing. So when you see this, which might be unfamiliar, it means the exact same thing as y equals 3x plus 1. Okay, but what exactly is that? So first and foremost, how do you say that? When you see this notation here, that is pronounced f of x. Or if you see this, we would say g of x. Okay, just for pronunciation purposes. Going a little bit deeper, what do all those things mean? F is the name of the function. Just like my name is Miss Mancini. The name of that function we're looking at is f, which differentiates between like f was the linear, and then you could say, okay, the name of the quadratic function was g. It tells you which function you're dealing with. The square root function was called p. Okay, then you'll always see something in parentheses, like you see the x here. That's always going to be the input into the function. And when we talk about inputs, it could be a variable, it could be a number, it's what you plug into the function. It's always your x value or what you plug in. Input, plug in. Then whatever it's equal to, that's going to be your output by process elimination. So in this case, your output is y, because in a function, inputs are x, outputs are y. Okay, so it's always going to be y or what you get out. Okay, so if I plug in 1 for x, what do I get out as y? That's your input and output. For example, when I made my table here for 3x plus 1, input was x, what you plug in. And when I plugged in 0, you got 1 for your output. Right, so this is your input, that's your output. Okay, more importantly, it might make a little bit more sense if I show you how we use that. So when you see something like evaluate f of 1, first of all, evaluate means to get a value. And a value is a number. Not a hashtag, but a number. So if I say evaluate f of 1, remember whatever's in the parentheses is your x value. So it's saying substitute 1 in for x, or it's your input if your function is not x and y, I suppose. So what this really means is if x is 1, okay, what is the output? What is the value of the output? And again, output is y. So what that's saying is if x is 1, what is y? Which you could solve for by substituting 1 in for x. So if it was like y equals 3x plus 1, we'd say, okay, x is 1. Let's substitute that in. Okay, 3 times 1 is 3, plus 1 is 4, y is 4. We've evaluated it because we got a value for the output. You would do the exact same thing here, just a different notation. So function notation relates the input directly to the function name and the output, which is why we often use this instead of using y. But same idea. So we would say f of 1 equals 4, which is the same thing as saying y equals 4. All of these things mean the exact same thing. It's just a different notation. Okay, so that's how you would look at it from an equation. We could also look at it from a table or a graph. So same question, if I look at a table, what is f of 1? Oof, that's an f. Or if I look at it from a graph, how would I find f of 1? And since you're looking at the same function, we're looking at function f. So I'm going to eliminate all g, p, y. We're looking at f, right? That's why we name it, so you know which one we're talking about. And if I said, okay, let's look at the table. What is f of 1? Student would answer, okay, let's find where x is 1. What is y? And you'd see it's 4. Exact same answer as if we use the equation. Or from a graph, you'd say, okay, what is f of 1? Well, student would find where x is 1. So here's where x is 1, because this is the x-axis, right? Here's where x is 1. On the graph, you're right here. And this point is x is 1, y is 4. Quick little reminder, you always write points with x first, then y. And you'd say, okay, if x is 1, the output is 4, because your output is always your y value. Whether it's a table, equation, graph, doesn't matter. That concept works the same way. It's just interpreting function notation. Okay, versus in example 2, you have g of x equals 16. So we're no longer working with our f, we're working with g. That's why we name the function, so you know which equation, table, graph, etc. you're working with. In this case, g of x equals x squared plus 7. So hopefully you're thinking to yourself, okay, I'm looking at g of x equals x squared plus 7. Miss Mancini that said it's kind of like the same thing as y equals x squared plus 7. By the way, that's probably not linear because it's got a square. It might be a parabola, hint, for another time though. Okay, and you could do that the exact same way is you're thinking about inputs, outputs. Now, in the previous problem, I gave you something in the parentheses. Okay, here you don't know what x is. Here you did. What you know here is what the answer is. So we're kind of going backwards. So you know the output, right? We know this part of the equation, not what's in parentheses. Which means what you know is that this time you know your y value. Because normally it's g of x equals y. So this says when y equals 16, what does x equal? Going backwards. So you could plug in 16 for y and then solve for x. Just a quick reminder, now we're solving equations. You would subtract 7 from both sides. You get 9 equals x squared. And I'm saying what number, when you square, is equal to 9? You'd say x is 3, right? Because 3 squared is 9. 3 times 3 is 9. Hopefully you're also saying, what about negative 3? Because isn't negative 3 times negative 3 positive? Negative times negative a positive? Yes, it is. So you actually have two answers for x here. X can be plus or minus 3. Okay, now I use y here, but that's the same thing for function notation. So it says g of x, actually let's highlight this. G of x is 16. So anywhere you see a g of x, you know it's equal to 16. So here's the g of x. We know that that's equivalent to 16. And you have the same type of equation. So I'm just trying to show you that these mean the exact same thing. But you have to interpret function notation and know that this is your y value. Whereas in the previous example, right, this was your x value. And you solve the same way. And you could also do that from a table or a graph. So let's say I had a table of this equation. I'm just going to jot up a table real quick, and I'll come back in a second. My quick table and graph. So same idea. Let's say I didn't have the equation, and I just knew that g of x equals 16. And you would say to myself, okay, that means y equals 16. What is x? Well, here's where y is 16. Here's where y is 16. You could just jump straight to the table and say x is equal 3 or negative 3. Or if you had a graph, you could do the same thing. So find where your y value is 16. So here's y 7. 16 would be all the way up here somewhere. You could find those points and say, I would have graphed this more specifically, but you'll get the idea. So those points would be these. You'd say, okay, when y is 16, my x is equal to 3 or negative 3. Okay, so whether you have an equation, table, or graph, you can use function notation to evaluate. Evaluate just means get a value. Okay, in conclusion, anytime you have function notation, this is the main thing you need to know, and I hope you wrote all that down, but if not, make sure you pause, go back, and do so. Quick summary. You say f of x. F is just the name, so that function was f, where that function was g. Okay, whatever's in parentheses is your input, your x value. Whatever it's equal to is your output or your y value, right? Or I guess it could be equal to the equation that tells you how to solve for the y value, but still. That's function notation. We use it a lot. And one quick thing I want to say is your inputs and outputs, they could be numbers, but if we wanted to get a little creative, they could be anything. So if I saw like g of a, that would just mean that the input is a. So you would take a and plug it in the equation, which was x squared plus 7, is now a squared plus 7. You could have g of smiley face, which means you would plug smiley face in for the input, or in for what x is. Okay, it can really be anything. It's just notation, right? It's just a variable. It's just a placeholder. X is a placeholder. A is a placeholder. Smiley face is a placeholder. Please don't hate me for throwing in smiley faces. I'm not trying to ruin your life. I just want to prove it doesn't always have to be an X. Okay, so that's function notation. We've already talked about functions. We're already off to what the foundation of algebra is. If you have any questions, please let me know. Otherwise, have a great rest of your day.